So today is going to be the average or mean value theorem for integration. And hopefully if you ever get a problem, either on the AP or later on this year, they are very specific as to which average or mean value theorem they're talking about. So basically, how would you calculate this area underneath this curve? What would you do? Well, if that was the curve, obviously I would probably give you some function, right? We'll call this maybe f of x, we'll call it. All right. Basically, to find that area, I'm going like this. How would you do that? Well, the easiest way is to use the fundamental theorem of calculus, all right, which says go from basically A to B, right, and take the antiderivative of that function. And which axis did I go to? I went to the x-axis, so it would be dx. Do you agree pretty much if I gave you a function now, you could do that? All right. Now, the thing that might seem strange and you're probably going to want to keep track of is this book kind of puts things in weird places. And so they actually put this before doing the fundamental theorem of calculus, which I thought was a very strange place to put it. So that's why this says 5.3 when the other notes say 5.4, the ones you've already done. That's why it seems a little out of order. Okay. Well, this is basically saying, and I think I have this right over there too, is yeah, that's what you would do. And what it's really saying is, let's say that had an area of 10. Do you agree that that graph right there from A to B is continuous? It's saying that there is some rectangle in there that will also have an area of 10. It's guaranteed to happen. And so obviously there is a certain y value we're going to be looking for, and the x value has to be between A and B somewhere. Who remembers what they called that value earlier this year when we did these average values? What letter did they use for that one in between? C. Exactly, they used C. Here they just use f of c a lot of times, or you can just say the y value if you want. It really doesn't matter. So basically what we're looking for is, yeah, we're going to find what's that basically definite integral, and then we're going to find that rectangle that would give me the exact same area. We're going to find the y value and then the x value that actually gives me that y value. They both have to be there. They're guaranteed. So probably the easiest way to do this is jump into an example here. And this is probably where you're going to want to use the graphing calculator a little bit to get an idea of what it looks like. So go ahead and graph 3x squared minus 2x from 1 to 4. Now, if I hit graph right now, it's probably going to be from negative 10 to 10, so that's probably not what we want. What's probably a better window for this particular one? Yeah, maybe 0 to 4, or even 1 to 4 if you wanted to, but I think 0 to 4, or maybe even 0 to 4. There you go, 0 to 4. I don't think my y is going to be very good. Probably 0 to, well, based on what I see there, why don't we go 0 to 40, seeing that's the axes I gave you. And let's take a look at what happens. Starts off very slow and then goes very fast. But once again, to get an accurate graph of this, what's probably the easiest way to get an accurate graph onto yours is use the table. So let's see, 0, going up by a half, probably not what we want to do. Let's just go up by a 1. And let's find out what it says. So 0, 0, 1, 1, 2, 8, 3, 21, and 4, 40. So 0, 0. Well, 1, 1 is not going to be very high, so we'll put it maybe right about there. 2, 8. Well, a little short there, probably. 3, 21. Right there. And 4, 40 right about there. Now, it's very important to know this is saying only from 1 to 4. And it does say dx. Well, it doesn't say dx in the problem, but we're going to the x-axis here. So that is something we can find. Any questions on getting the graph to kind of figure out what we're looking for? That's pretty straightforward. We've done enough of that. So to actually calculate that, let's go 3x squared minus 2x, of course, dx, from what to what?
4 on top is 4.
On top is 4, I agree with that. On the bottom is not 0, but 1. Yep, because right here it says only from 1 to 4. I chose this particular function for a reason, and that's because its antiderivative is not too bad, because it'd be basically, there's a 3 there, so it'd be x to the third over 3, so those cancel, minus, so there's a 2, and then x squared over 2, so those cancel as well. So really it ends up just being x to the third minus x squared. And remember the notation, it's good to remind yourself that you have taken the antiderivative and get rid of that. Now what we need to do is substitute in the 4. So you put 4 in here, and 4 to the third is 64. Minus, now it's minus because of the one that's actually in the problem, minus whatever 4 squared is, which is 16. Again, I put parentheses around that so I know that's what I got when I put the first number in. So if I come back and look at this, I can understand what it was I was doing. And then minus, and I like to do it this way. Now let's put 1 in. Well, you put 1 and take it to the third, that's 1. Now the minus is actually in the problem. Well, 1 squared is also 1. So really, I'm just subtracting nothing right there. So it's 64 minus 16 is all we really have to take a look at, which is 48. You could say unit squared if you wanted to, most definitely. So the green shaded area here has 48 as an area. Unfortunately, when asked for they're asking me here to find C guaranteed by the mean value theorem. So remember, C is the x value. Is 48 the x value we're looking for here? No, 48 is the area. And we're guaranteed that somewhere along the line that there's going to be a rectangle in there that has an area of 48. Well, the nice thing is we already know how big the bottom of this rectangle is. It's 1, 2, 3, right? Because it goes from 1 to 4. And all you have to do to figure out how wide that is take B minus A. Because let's face it, this is B right here, that's A right there. So basically, how wide is my rectangle going to be? It's going to be from, well, how do I write it? From here to there is 3. So how tall does this have to be, this rectangle? 16. All you did was take 48 and divide by however far you went, which was, in this case, 3. So you might want to make a note of where the 3 came from on your notes so you don't look back and say, I don't know, do you always use 3? Or how does that work? Well, it happened to be that's how wide what I was looking for happened to be. And again, that would be 16. Is 16 the x value? Yeah, 16 is actually the y value. Do you agree that 16 as a y value will happen somewhere in this range that we've been given? Yeah, and so it's probably, where do you think 16 is? So right about there is maybe 16, so somewhere in here, right? So it will look something like that, right? So we know it's 3 by 16, we know that's also going to be 48. So in other words, this stuff that's not shaded in green on the outside of this rectangle kind of gets canceled out by that stuff over there. So that's believable. So how do you figure out that x value? I want the x value. Brian, go ahead. Perfect. Take this 16 and put it right there because that's where y values belong anyways. Now notice he told me to go where? Did he say go to the antiderivative? No, he said go back to the original, which is exactly what we're looking at. So you put 16 in there, so 16 equals 3x squared minus 2x. Now I think we've seen enough quadratic problems to know that there's probably going to be 2 answers to this. Let's face it, we're only looking at part of the parabola in our graph, correct? So we only want the answer that's going to work for us. So you have a lot of options here, but what I would do is get it equal to 0 and then try and solve. I think a lot of you might just go to quadratic, which is fine. So here, I'll write it down here. The easiest way is to subtract 16 from both sides, and then it'll equal 0. Yeah, I'm one that likes to try key number. I like to at least try it because I'm not, it's not that quadratic's that bad, but I try to avoid it as much as possible. And this one, it multiplies to be, remember, it'd be like this, negative 48, and adds to be negative 2. And we've been told that those numbers do exist. And they are negative 8 and positive 6. Very good. Remember, this one gets split. You can't use the extreme shortcut on this one because there is a number on the quadratic term. There's a 3 there. So the splits, does it matter which one you write next, the negative 8 or the 6? But I'm looking at this 3 out front, and which of those two numbers is going to go better with the 3? Yeah, 6. So let's write that one first. And then minus 8x. Well, that works out nice because then 8 works a lot better with the negative 16. And this is the extremely non-technical term that we've used, and that's the squiggle. Notice I took the sign with the second hand. So we got a 3x in common here. So we're left with what? X plus 2. So that's what has to be over there. Can I get it? Can I get x plus 2 over there? Yeah, I got to take out negative 8. So my factors are x plus 2 and 3x minus 8. And again, they are to equal 0. If at any point you need me to slow down, let me know. So from this first one, we get x equaling, is that a very helpful answer, seeing we're supposed to be going from 1 to 4? No, because the mean value theorem is guaranteeing that between 1 and 4, this is going to happen. We're going to get 16 somewhere. Yeah, that one doesn't help. So we got to look at this other one. So basically, you get, what, 8/3 for that one? Otherwise known as 2 2/3. Does that fit in the range like we were guaranteed it was going to? Most definitely. And let's see, how close does our graph, how close did my graph actually get? So if we go 2 2/3, we're looking right about there. Actually, I did pretty good. Not bad for freehand. Okay. So again, if they're looking for the C value, remember, whenever they're talking this average value, mean value theorem, they are looking for X right there. And a lot of times, if they just kind of ask you for that mean value, they're asking for the Y. And so in this case, that would be 16. So any questions on that? So a lot of the math and algebra that we've done is kind of working its way together. The question was, can you ever calculate putting in 16 as the Y value? And yes, there is, and I will eventually show you. So this one, ooh, the axes I gave you look a little on the scary side. But let's take a look at 4 minus x squared from 0 to 3. All I'm doing is setting my window to what was pretty much on the axes I gave you. And once you have that, probably go to the table and get some accurate points. So we got 0, 4, 1, 3, 2, 0, and 3, negative 5. The question was, do we have to break these down into two things? And it's a very good question. And actually, no, we don't. we just let the fundamental theorem of calculus take care of finding that number for us, and we find the rectangle that it guarantees. Because otherwise what might happen if we break it up is we make them both positive, the area might get too big, and I won't be able to find the y value that'll make it happen. Okay? And so it's very important for me, so that you understand the graph, basically it's that and that, because it's always to the x-axis. And if you've got that figured out, you're on a long ways towards figuring this stuff out. And I'm going to get it set up for you, and then I want to see what you come up with. There you go. Find me C.